All right, good evening. So this is going to be a little bit of an intro to class, and I'll take you through the first little bit that we have going today. So I am not the most proficient at the online learning type of thing, and Brightspace is really new to me. So I know there's a lot of different pieces in the class, and I'm doing my best to learn how to link everything together and make it all work. So I appreciate your patience so far, and I'll be working on trying to make this a better experience for you. But if something's not working, see if you can't let me know, and I'll see if I can't fix it. And that being said, if something ain't working, I'm gonna put the due dates back a little bit, and that's the way it's gonna be. I don't really know. Um, we copy the classes from other people, so whatever the schedule is, I'm sure was an optimistic vision of the class. So that being said, if it's not quite working out for us, let me know, and I will move things because we can make those rules. All right. So I'm going to go ahead and share my video here. I'm going to share my screen so you can see what I'm talking about, and then a little bit after getting into the class, we're going to start our first lecture today. All right, so let me go ahead and do that. All right, so there we go. So here's your class. If you haven't gotten in to start things yet, that's okay, we're there. So we're gonna go hit content. All right, and I'm gonna go ahead and do this for other things. So the thing you're probably sitting in here is this one. Let's see here. I need you to deal with the students. We've got class lessons and work on that. Actually, I think we're done with it. Yeah, we are. So I will open those today and figure out when exactly we're going to have our classes. I'll put an announcement to let you know. What I really want you to do sooner rather than later is to hit this guy here, the Alex materials. Okay. And what we're going to do is we're just going to click on this. You're not going to see all of this stuff. This is, like how to build a class kind of stuff. I get those tools. But we're going to go in through here and let's see what we have. Okay, there we go. Please wait. Thank you very much, Alex. And you've got this pie slice type of a thing, and I got some of this. And there we are. So what I'm going to do first off here is go to my assignments and manage those. And your first job is to go through this initial skill check type of a thing. Okay, that's your deal. So I would urge you to go through that. You're not graded on this. Okay, the more you can do legitimately, the easier the class is going to be. But if you try to skip it, then it will test you a little bit later, and then if you don't do that, it'll set you back to where you didn't do it before. So I would appreciate if you just gave this your best honest try, and like I said, wherever the chips lie after that is where they are. Okay, that gives me a good idea of where you are and what we should be spending our time on. That being said, if you email me questions, I will not out you as far as, this person said they didn't understand whatever. I will just cover it, and you'll usually start off with just saying something like, some students have asked, and I'm not going to use your name. Okay, so if you want to email me a question or you want to do that some other way, I'm not gonna put you on the spot for anything. If you're attending the Zoom things and you ask a question, then I either have to open up comments, which people will see your name that way, or people will hear your voice. Now you can change your Zoom name to be whatever you want. Don't do something where it's gonna affect people seeing it online and making bad words or anything like that. I probably should have suggested that. But if you want an alias because you want to ask a question and you don't want your name out there, I don't think anybody is going to have a problem with that. But that being said, I also don't think the interest in my YouTube videos are going to be such that people are going to be pawing through however long this is to find your name so that they can do something to you on the internet. There's more things to be afraid of than that. But so don't worry about asking the questions. I doubt anybody will ever know. Okay, and if you feel bad about that, then shoot me an email. Again, I'm not going to do anything to you for that, so I'll take that for that. Okay, so go through the initial general knowledge check. I think this takes about an hour. If you're not really sure, maybe schedule 2 hours, but I think this should take about an hour. Then let's go ahead and take a look at the first thing that we're going to be looking at here. Okay, so let's go ahead and hit preview here, and we're just going to start. Okay, again, unlimited, and they just start us off with some graphing. Like I said, I'm just going to go through this, and hopefully it'll go about an hour for this. But I taught the statistics version of this class last semester, and I had only one person ever log on for my lectures. But we would go through the homework, and she would sit there and follow me. And even though she had slightly different homework problems, I would just talk her through the whole thing. She did really well with the whole class. She felt like she knew what she was doing at the end of it. She did email me in a panic. I'm like, wait, I've never seen this before. I'm like, yes, you have. They're in this chapter. I'm like, oh, I got it. Okay, cool. We got this. And that was all the push she needed. She was great. So, I urge you to, and that's as much outing as you'll ever get out of me either, because I'm not going to give you a name. I'm just going to say, oh, this one student did this. Nobody will ever know it's you. Okay. So if you want to follow me with the with the lecture videos and do your homework as I'm talking to you to go through it, that's probably a great place to start with this. So I don't know if how much of this you do know. So what we're going to do, we're just going to go through. Okay, I'm just going to say, well, these are X's and these are Y's. Okay, these are X's and these are Y's. So every time you have this, let me go ahead and do it this way. I like to write more than I like to do on the computer. But every point you have, right? Every point you have an X and you have a Y, and it always goes in this order. Okay, so this is the horizontal, and this one is the vertical. Okay, as we go, right? We have quadrant 1, quadrant 2, quadrant 1, 2, 3, quadrant 4. Okay. Both of the ordinates, that's what they call this. Coordinates would be the couple, but the ordinates, they're both positive here. In this case, we have a negative and a positive. In this case, we have both negative. Quadrant 3 is both negative. Quadrant 4 is we have positive X's and negative Y's. So these are the mismatched ones here. Okay, and we're just going to go through a graph and see how far we can get with this. All right. So here's the key on this one. It says approximate irrational numbers to one decimal place and use of graphing. Okay, and I'm not going to promise I'm going to get all these right because I don't have the patience to go through and very delicately make sure I've calculated or I've counted each of these tenths. I think that's what these are in. So first one is -3, -2, right? So we're just going to go down with the -3, -2. The lines are nice. They hold us up there. Okay. 5/3 and 7/2. Well, that's a beautiful number. 5/3. Okay. Well, here's how I'm going to think about this. 5/3, right, is a little bit smaller than 6/3. Well, 6/3 is 2. So 5/3 is a little bit less than that. So maybe we're going to go down about here. And then 7/2. 7/2 is a little bit less than 8/2, right? 8/2 is going to be 4, right? 6/2 would be 3. So it's somewhere between 3 and 4. It's about halfway through. Oops, we're going to move over here. So I'm looking at the bottom level is about 2/3 of the way through. And then we'll hit that one. Okay. Next one is -2.5. So that's over here. I think we're here is better. And then 3.1. You can see I'm like scrolling around a little bit. It's kind of holding my position. Okay, so I'm kind of hoping that that's going to go. 2 and -pi. All right, 2. Pi is an irrational number. It's like 3.1 something. So what do we say? It's 2 -pi. So we're going to go to 2. And we're just going to call it -3.1 because that's what they suggest to do. Okay. 0, 3.8, so 0, and then E is 3.8. That's going to be all the way the heck up here. I think these are tenths, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's convenient. All right, and then square root of 7, well, here's how you think about that. I mean, you can punch this in a calculator, that's fine. But square root of 7, square root of 9 is 3, right? So it's a little bit less than 3. So we have 0, it's going to be a little bit less than 3. So I'm going to guess about there. Okay. And now we're going to do a check. And hopefully we got these. Oh, how about that? It took it right. So that was nice. Okay. It's just graphing some points. That's important. We're going to be doing a lot of that. Okay. For the points, find the exact distance between the points and find the midpoint for the line segment whose endpoints are given. All right. This is like the first thing you do in college algebra, really, is something like this. All right, so let's talk about a couple of these things here. For midpoint, okay, if I asked you, and I said, well, I'd like to know what number is between 1 and 3. You're going to say, well, of course, it's 2. And I'll ask you, like, how'd you do that? And now you have to think about that, right? Because what algorithm did you use, right? If I ask you for any other 2 numbers, would it be that easy? See, in this case, you can just kind of estimate and say, well, I know 2 is between them. But really what you did is you did that, didn't you? You averaged them. So we have 4 over 2 is equal to 2. And that's going to work all the time. Okay, so to get a midpoint, right, we just average the 2 numbers. We just average the 2 ordinates. So it's halfway between the x's and it's halfway between the y's. Okay, so if I want to get my midpoint, okay, what we're going to do is we're going to take 1 plus 2 over 2. So we have 1 and 2 here. Okay, that's my x coordinate, right? That's my x midpoint. And then we also have negative 2 plus 5, and that's my y midpoint. Okay, divided by 2. All right, so in this case, we're going to have 3 halves. And in this one, we're also going to have, right, negative 2 plus 5, that's going to be 3 halves. All right, so in both of these cases, we end up with 3 halves. We're going to have to, oh no, we don't have to wait. So we're going to say 3 halves. You can use all the buttons. I mean, it's fine. Do however you're comfortable dealing with this situation is fine. Now, distance, that's a little bit more involved. Okay, so let's walk you through what distance means. And I can't promise you you're going to have formulas for this, because I don't think I've ever given formulas for distance. But let's go ahead and give a little graph of these things, okay? Let's go ahead and draw us a picture. All right, so they want to know what? 1, negative 2, and 2 and 5. Okay. So we have, oops, I want to write. We have 1, negative 2, and 3 and 5, right? That's the 2 points we have. So if I were to graph this thing, right, using the skills we just practiced in the last problem, right, we have 1, negative 2, and then 1, 2, 3, 1, 2, 3, and then here, okay, so here, right, 1, negative 2, and then 1, 2, 3, 5. So here, right, 1.5, we'll go off and say something like that. We'll pretend that that's 1.5 there. But to get the distance, really what we're doing is we're making a triangle. What's the x distance between this point and this point? Okay, well, that's 3 minus 1, right? That's 3 minus 1. This side of this triangle is 2. What about this one? Well, we're 5 up, and we've got an additional 2. So that's 5 minus negative 2. That's 5 plus 2. That's going to be 7. So this value here, this is 7. Okay? And what we're going to have now, right? If I said, well, here's a triangle, and this side is 2, this side is 7, tell me what the hypotenuse is. All right? You could do that. I know you could do that. Maybe it's been a couple of years. but we're going to say hypotenuse, right? C squared is equal to A squared plus B squared. Remember that? So we're going to say C squared is equal to 2 squared plus 7 squared. Okay, and just as we're going through this right now, what happens, these aren't negative, right? But they, well, you could find a situation, they won't be negative, but maybe you find the coordinates are going to be negative. What happens if I square a negative number? It turns into a positive number, right? So if your calculator says this is negative, you know better. It's not negative, it's positive. So, you know, we have a 4, right? 2 squared is 4 plus 49. And then 4 plus 49, I think that's going to give us 53. But I don't want C squared, right? We wanted C. That's going to be the square root of 53. And I don't think that has a very nice, there's nothing we could do with that. Okay. Now, in the book, you're going to see a formula. You're going to see x2 minus x1 squared plus y2 minus y1 squared. Right? We're gonna pause this for just a second here. Let's shoot. Stop sharing. There we go. Hold on one second. All right, there we go. Sorry about that. Let's see here. Sharing. All right. Sharing the screen. So yeah, you're going to see this formula, which is horrid, okay? But all it means is get the x part of the triangle, get the y part of the triangle. So this is the horizontal distance. That's the vertical distance. And then this is just a thing for the triangle, the Pythagorean theorem, right? They instead of a C, they're using a D for distance. All right. So you see this formula. I know this is a little intimidating. Learning how to use this would probably be a good thing, but you know what? If you didn't learn how to use it, or if you have a fallback, you say, "Oh, I can't remember the formula." Draw the triangle. Life will work out. Okay, that's what this whole thing is based on, is this triangle. So this distance formula is really this triangle. So even if you don't remember the formula, you should be able to go through and actually do this. So we have our distance is the square root of 53. So we're just going to go ahead and write down here square root of 53, and then we're going to go on with our lives. All right. Oh, it didn't like that at all. What do you mean? It should be the square root of 50. Oh, is there a thing? Is there a thing where I did not? I'm trying to think if 53 is a prime number, but I don't think it is. What did I do? Yeah, one last time. Go ahead. What are you telling me? So I squared to 2. That ain't right. What did I? Oh, that's why I screwed up. Look, 2 minus 1. The distance here is only 1. Ah, here it is. Okay, so that's what I messed up, right? It's not 3 minus 2, it's 2 minus 1. There we go. All right, so let's go ahead. That's not going to be a 2 anymore. This is going to be c squared is equal to 1 squared plus 7 squared, which is equal to c squared is equal to 1 plus 49, which is 50. So c squared is equal to 50. Here's how they got the answer they did. 50, though, right, is equal to 25 times 2. So if I want to take the square root of 50, we're going to get the square root of 25 times the square root of 2. And that is equal to the square root of 25 times 2. And that's how they're getting 5 square roots of 2. All right? So I should have taken my own advice on this one and double-checked where I started, because that's usually the problem, is writing down the problem incorrectly. But, you know, everybody can make that mistake. All right. So let's go through and do a little bit more. All right. So I guess we're continuing. I've got the stain of dishonor on me here. Oh, harder one, right? Now we have to do arithmetic. Okay. So similar problem, right? So I'm kind of curious, how many of these are we doing here? Exact distance. Tell you what, in order to make this thing not forever long, why don't I pick this problem? Because this looks a little bit more difficult than this. This is the same problem as before, except with decimals. All right. Let's look at this problem because this looks a little bit scarier. Okay. So what are my 2 points? Okay. 2 points are the square root of 3 and 2, square root of 2 rather. And then we have 2 root 3 and negative 5 root 2. Okay. And we need the distance and we need the midpoint. Let's do the midpoint first. I don't know why they ask it this way. I mean, I know they introduce distance formula before they introduce midpoint, but quite honestly, midpoint is easier. So to get the x's, right, we're gonna average these. We're gonna take square root of 3 plus 2 root 2 divided by 2. Okay, sorry, this is a square root of 3 as well. So we got square root of 3 and square root of 3. We can add this together. We have 2 square roots of 3 plus 1 square root of 3. That gives us 3 square roots of 3 divided by 2. That's about all you can say for that. Okay, this is 1 square root of 2 and plus a negative 5 square root of 2 divided by 2. Okay, we have 1 square root of 2 minus 5 square roots of 2. Wouldn't that mean we have negative 4 square roots of 2, which is equal to negative 2 root 2? Okay, I'm sure these are delightful numbers, all right, but we don't have to worry about trying to figure out exactly where this is. There's our midpoint. All right. There's our midpoint. So we're going to have 3 root 3 over 2. Oops, tell you what, we should probably write this thing as a point, right? And then we have negative 2 root 2. Okay. Now you can't add a square root of 3 to a square root of 2. All right, but you can certainly add square roots of 3's together. All right, so if we ended up with a midpoint that would look like, say, square root of 3 plus square root of 2, like there's nothing you can do with that. Okay, it's like I've got a yen and a euro, and how much do I have? Well, you've got a yen and a euro, and you're stuck. All right, so if you got 2 different kinds of square roots, you're not doing a whole lot with this. Okay, multiplying is different, but adding, you're just kind of stuck with this. All right. So let's see, let's go up to part 1. So here again, we have a triangle, right? So what's the x distance, right? Is whatever this triangle is, right? We've got a square root of 3 and we have 2 square roots of 3. So how long is this distance here? This distance is 2 square root of 3 minus 1 square root of 3. All right. Let's draw the triangle in the proper configuration here. Because one of them is really negative, right? So we have square root of 2 and negative 5 square roots of 2. So we'll call this one, this is square root of 2. And then down here will be negative 5 root 2. But still, what's the distance here, right? What is the distance? So we have square root of 2 minus a negative 5 square roots of 2. That's going to be 6 square root of 2, isn't it? Okay. So we have to go negative 5 and then an additional 1. That's why it's 6 square root of 2. All right. And again, we have a triangle. Okay, we have a triangle. We have a triangle that looks like square root of 3 and then 6 root 2. And if I asked you, hey, what's that hypotenuse, right? This may not have been the most enjoyable question you had when you learned triangles and Pythagorean theorem, but it was a question you could do. Okay, so my d is equal to, or let's stick with the triangle, right? C squared is equal to square root of 3 squared plus 6 root 2 squared. All right. What do you think the square root of 3 squared ought to be? How about 3? Now this one is going to be a little bit more complicated because we got to square both of these things, right? It's not, it doesn't work. It doesn't work like arithmetic, but it kind of does. But we need this 2 to come both of these guys. Okay, I really would rather not say it that way, but because I don't want to get you just confused with that and distributing things. But 6 squared is 36 times square root of 2 squared is 2. Okay, so what's 36 doubled? It should be something like 72 plus 3. That's equal to my c squared. So c squared is equal to 75, which is 3 times 25. So when I do c, that is the square root of 3 times 25, which is the square root of 3 times the square root of 25. That's my heater. I'm sorry for that. Okay. That'll get less frequent as we get closer to spring. But in the throes of winter, we are going to have to suffer with a heater. All right, but there's my distance. Okay, so there we go with that. So my distance here is 5 square root of 3. So 5 root 3. And we already have my value here. And I should probably close my, right, and hopefully there it'll solve. Right, okay, good. All right, so let's see here. Determine if the solution, okay, let's see, it's a 5, it's 6. Okay, let's go ahead and look at this one. Okay, determine whether or not the points are solution to the equation. All they want you to do with this, okay, so quite frankly, this is actually a differential equations question as well. Because they give you a solution and they say, does this work? Okay, so all they want us to do is say, well, we have an x and a y, and is that equal to 8? So we have x squared plus y equals 8. So x squared plus y is equal to 8. And they want us to check out all of these things. Okay, so how about for b? Right, for b, it says x is equal to 8, y is equal to negative 56. So plug in 8 here, right? We get 8 squared minus 56. 64 minus 56. Is that equal to 8? And I believe it is. So B would be a solution. Okay, B would be is a solution. Okay, let's walk through C because it looks hard. Okay, but we have 1/4 and 1/27/16. And again, they didn't change the rules. We still have x squared plus y is equal to 8. Is this true? So here's 1/4 squared plus 127/16. What's that equal? Well, 1/4 squared, right? That's 1/4 times 1/4. That is 1/16 plus 127/16. And that is going to tell me that it's really 128/16. Okay. And I've got a calculator emulator here. Right, so this is going to give us 128 divided by 16. And that is equal to 8. So that's true. So part C would also be, yes, this would be a solution. Okay. All right, let's go on to the next one. Let's do this one. That way I can clean this one off. So we have 8 and negative 53. So 8 squared minus 53. So that's 64 minus 53. I don't think that's 8. I think it's 11. Okay, so this would not be a solution. All right. And then we're ready to go on to the next one. All right. So there's going to be a lot of this in this class. A lot of college algebra is learning how to graph things and learning the shapes of graphs. All right, that's a big part of the college algebra part, is being able to look at points, being able to look at a function and get an idea in your head of what this is supposed to be. So let's go ahead and pick some points here. So we have this t graph, right? We have this t table. We have x's and y's. Now we're talking about square roots, right? We have y is equal to the square root of x. So with my x's, I want to pick things that are going to be nice square roots. So like, what's the square root of 1? It's 1. Square root of 0 would be 0. Can I put negative numbers in here? Nah, that ain't going to work. But do I want to pick 2? Not really. That's an ugly square root. But how about 4? Right? Square root of 4 is 2. And how far out do they go? Let's go with square root of 9. And the square root of 9 is going to be 3. Right? So here we go with our pencil and some tools here. So just to and this is a good problem. We should practice with using these tools. Plot at least 4 points. So there's 1. There's 1. Okay. 4 and 2 and 9 and 3. Okay, so these are my points, but we're not done yet. We got to hit that. Okay, so we have 4 points on here, and we are ready to go with that. All right, we'll say check. They have better tool tips for the graphs. So if you did get a one that was kind of a weird one to go with, later on, they will open up more tools for us so we can get a better result here. Okay, and when we get there, I will show you how to do that, and we'll just go from there. All right. So graph the equation again by setting points. Absolute values. This is everybody's favorite. Okay, trust me, I will tell you. I'll tell you early. When I was in high school, I was not very good at math. Okay, it really wasn't. It wasn't until I think I got like not quite held back, but definitely put into the the lower group. So I kid you not, like, I'm sorry, with Gen X, they don't lie to you. They just tell you, like, they don't care about your spirit. They just, you're there to be crushed. But we had like gold group, silver group, bronze group, and I was down like at boron or something. Okay, that's where I was. And we knew, right? I mean, you watch the Olympics, you know what gold means. So no matter how old you are, you know which group you're in. So I was not in a very powerful group. And I hated absolute values. So when you're looking at this and this causes some kind of problem for you, I absolutely feel your pain. Let's start with 0. Notice I start in the middle because I want positives and negatives here. So this is just 2 times the absolute value of 0. Well, the absolute value, what does this do? It just changes it to a positive. So we just have 2 times 0, which is 0. Right? If I put in 1 here, right, that's a 1. It's got serifs. We have 2 times the absolute value of 1. Well, 1's positive, so the absolute value of 1 is 1. 2. Plug in a 2 here. We have 2. Absolute value of 2. 2 times 2 would be 4. Okay. Let's try negative 1. Right now we get the interesting ones. Okay. So absolute value of negative 1 is 1. 2 times 1 is 2. Negative 2. We have 2 times negative 2. Absolute value of negative 2 is positive 2. 2 times 2 is 4. Okay. So yeah, they held me back, not quite held back, but they put me in the boron group for learning math. I got through 9th grade with that setup, 10th grade with that setup. And come 10th grade, I started learning a little bit more about, I don't want to spend my life like this because I did not do this to the teacher, but this was certainly a thing. My class did their best to make the teacher cry on a regular basis. Okay, it's not fun, and we did. We were terrible. When I got to go to work the summer between my 10th grade and 11th grade class, and I was working at a place. I was like the miniature golf guy, and I asked the school, I begged them, like, can I please have a geometry book to learn something over the summertime? And eventually they conceded because they, well, these are going to the dump anyway, so I guess you could have this one. Thanks. But being like the guy who like goes and fetches miniature golf things and counts up the scorecards for kids because that's what my job was, and going to fetch balls for people who hit them off the cliff. But I had a lot of time in the afternoons to just do geometry. And since I was sitting there at a miniature golf course anyway, it took. Something happened. Okay, so that was when I started getting better. And then when I took trig when I went to college, and I had a pretty good teacher for that too. She was good. So again, we'll go with 0 here. Okay. How about -1 and -2, +1 and +2? Generally, these are the points you want to pick. Okay, nice easy ones. So 0 cubed, 0. 1 cubed, that's 1 times 1 times 1. This is going to be 2 times 2 times 2, 2, 4, 8. All right. -1 is -1 times -1 times -1. Well, that's going to be +1 times negative again is -1. 2 is -2 times -2 times -2. So that's going to be +4 times -2 is -8. So let's go ahead and plot some points here. So we have our 0. We have our 1, 1, and our -1, 1. Okay. And then we have 2. And then I've got to figure, okay, well, here's 5, 6, 7, 8. And then here's 2. And then 5 down, 6, 7, 8. All right. And we'll go with that and we'll say, how we doing? All right. So getting used to these functions is a good thing. I know for some of you, this is going to be like, really? This is all you wanted? Yeah, that's all they want at the beginning. Okay, there's already enough to do. All right, so here we are with this. All right, I need time now. Oh, that's time. I still got my homework here. Okay, estimate the x and y intercepts from the graph. All right, the intercepts just mean, well, one of the variables, one of the coordinates is 0. Okay, that's all that means. So the x-intercepts, right, that's going to be where the x is, where it crosses the x-axis. Y-intercept where it crosses the y-axis. All right. By the way, I get those terms mixed up a lot, but if you remember, y equals mx plus b, and this was the intercept. This is the y-intercept. Right, this is where it crosses the y-axis. Okay. So, x-axis, where does it cross? Okay, where does it cross the x-axis? Well, that would be here, right? That would be right here. So that's going to be where it crosses the x-axis is -5, 0. All right, so that's -5, 0. All right, there we go. And let's see about the y-intercept. Where does it cross the y-intercept? Okay, and there's 2 of them, right? There's 0, 1. Right? When you're doing intercepts, I never really cared too much about what you guys called them, but in COVID times, I guess we have to worry about this. 0, -4. All right. If your intercepts do not have zeros in them, you do not have intercepts. All right. So somewhere on this point, there have to be a 0. All right. So let's see if I got them in the right order. All right. Hooray. All right. So let's see. Again, find the x and the y-intercepts. That's not too bad. This is a nice line. Okay. This is still pretty bad. All right. So what are we doing? All right. So effectively, we have the same kind of a thing, right? We have x squared is equal to -y plus 9. So not a function, but right, if I add y to both sides, we could write it this way. And now we could have -x squared, right, plus 9. That might make it a little bit easier if we make it look like something you're used to dealing with. by the way, that is a lot of math is problem recognition or is problem recognition. That way you could look at it and think, well, do I know how to solve that? So, okay, let's go play with this. So intercepts. How about when x equals 0, what's y equal to? Well, if I plug a 0 in here, right, we get y is equal to 9. Okay. How about when y is equal to 0, what's x? So what we have here, right, is we have negative x squared plus 9 is equal to 0. Okay. Or conversely, right, 0 is equal to negative x squared plus 9. Okay. But this is the same thing, right? I could tell you that 5 is 2 plus 3, or I could say 2 plus 3 is equal to 5. Either way I write this, it's correct. So it doesn't really matter which side you write things on in this case. Right? Let's go ahead and add x squared to both sides. So we have x squared is equal to 9. What number can I put in here when I square it to get 9? Well, how about x is 3? But don't answer yet. There's another answer, right? What about negative 3 squared? What's that going to do for me? That is also going to be a solution to that. So here are our problems, right? We have our y-intercept of, what was our first one? Of 0, 9. We have our x-intercepts, 3, 0, and negative 3, 0. Okay. So x-intercept, negative 3, 0, 3, 0. Okay. And y-intercepts are 0, 9. Right? I did not use the end. I kind of want to check to see whether or not it works, but we will obey. Okay. So let's see here. All right. Nice problem. Find the x and the y-intercepts. This is actually the equation of an ellipse. All right. So in the way, the method we teach this in the next class up, right, the pre-calculus class, is we tell them like, hey, you're going to use method of intercepts in order to figure out what's going on here. Okay, so we're going to let x equals 0 and y equals 0 and take turns with all of this. All right. I have a rule that says that if we assign a problem, then I should be willing to do it. Right. So, if you're stuck with something, I'm not going to say, I'd love to say this, but, it's a thing about math books of, the rest of this exercise is left, or the rest of this exercise is left as an exercise for the reader. The rest of this problem is left as an exercise for the reader, which, oops, not x squared there, x plus 6 squared over 36 plus y plus 4 squared over 9 equals 1. All right. Which one you want to do first, right? Doesn't really matter. It looks like we're kind of in trouble either way. So yeah, let's have it with this. How about we set x equal to 0? Okay, so we have 0 plus 6 squared over 36 plus y plus 4 squared over 9 is equal to 1. 6 squared, isn't that 1? Right? 6 squared is 36, and that's going to be 1, isn't it? Plus y plus 4, 9 here, squared is equal to 1. Well, these are going to cancel, aren't they, right? We subtract 1 from both sides, and then we get y plus 4 squared over 9 is equal to 0. Multiply both sides by 9 here. 0 times 9 is also 0. So I have y plus 4 squared equals 0. All right. And I know this is jumping the gun in your class a bit because you're still learning intermediate algebra, but we're going to use something called square root principles. We're going to take the square root of both sides. Okay, so we get y plus 4 is equal to technically plus or minus 0. But since plus 0 and minus 0 are the same thing, we're just going to call it 0. So we're going to go ahead and hit y is equal to negative 4. All right. So when x equals 0, y is equal to negative 4. Okay. How about when y equals 0? So when y is equal to 0, what do we have here? We have x plus 6 squared over 36. And we have, 0 plus 4 squared over 9, and that's equal to 1. All right. So we have x plus 6 squared over 36. That is plus, right? Don't want to jump the gun here. That's 4 squared, right? Could I say that 4 squared is 16? Are we okay to do that? Like, we see that 4 squared is equal to 16 ninths equals 1, right? We're not squaring the bottom, it's just the top. So it's 16 ninths. So here we have x plus 6 squared over 36, right, is equal to 1 minus 16 ninths. Now, what do you know about 16 ninths, right? The 1 is really a fancy way to write 9 ninths minus 16 ninths. Isn't this going to be a negative number? Right, isn't it going to be like 7 ninths or something, negative 7 ninths? And what do we have over here? Well, that's positive. 36 is positive. No matter what we put here, we're going to square it. That's going to be positive. So we got a positive over a positive. Anyway, that's going to be negative? No solution. So this thing does not have any x-intercepts. It just means that we don't cross the x-axis. All right, that's all that means. We do not cross the x-axis here. We cross the y-axis once, right? At y equals negative 4, we cross that axis, but we don't cross the other one. Okay, so that's all we have. There is not one. So let's go ahead and have a look at what's going on here. Okay, x-intercepts, none. Y-intercepts, there's one of them. There was 0, negative 4. I think that was right, yeah. Was it positive 4 or negative 4? Negative 4, very good. All right, oops, I don't want to search, I just want to do this. All right, there we go. All right, so let's just double check to make sure. I'm just doing a check to see, is there anything else in here? Oh, my favorite problem. Okay, so if I look back on all the college algebra exams I've ever given, this problem like this is pretty much one that pops up all the time. So we should probably do this one just to end on a note of like, I will probably, if I have a chance, if I get to pick which one is which, I'm picking this problem. Okay, I love this problem. So we have the endpoints of a diameter of a circle, and what we have to do is figure out what is the center and radius of the circle. Okay, so to figure out the center, would it make sense that this would be the midpoint somewhere in here somewhere? It's halfway between the two endpoints is the center. And then to get the radius, right? Well, here's our triangle inside here. We would get this whole hypotenuse. And that's the diameter. What do we know about diameters and radiuses? Right? Radius is half the diameter. So as we're setting this thing up to play, right? The midpoint, that's not so bad, right? We have midpoint between 1 and 1 and 4 and negative 3. This is going to be 1 plus 4 over 2, comma 1 minus 3 over 2, right? We're just adding these together. So we have 5/2. 1 minus 3, right? You have $1, you spend 3 of them, that's -2. -2 over 2 is going to be 5/2, -1. Okay, so here we are, about 2.5, -1. All right, so that's not so bad, right? We got the answer to be about right here, and the answer looks to be about right there. Okay, so just by looking at it, right, it's physical intuition, you can kind of tell. Distance, that's going to be a little harder, right? Distance, right? Here's 1, 1. And here is 4, -3. So I'd like to know, like, well, what's the distance between these points, right? And in this case, it's not kind of nice. You can actually count it, right? There's 1, 2, 3, right? So we do 4 minus 1. So this distance here on the triangle is 3. Now we got to figure out that distance. And again, we can say 1, 2, 3, 4. Okay. So 1 minus a -3 is equal to 4. All right. There's my triangle. Can we figure out what the halfway point is? Right. So we have c squared is equal to 3 squared plus 4 squared, 9 plus 16. C squared is equal to 25. So c is equal to 5. Right. So that's the distance between this point and that point. It's the whole thing. That's the diameter. I don't want the diameter, right? I wanted the radius. So this is my diameter. But the radius, right, is the diameter over 2. So that'd just be 5/2. All right. So there we go. Excuse me. So the center, let me do with that one. So that was 5/2 and -1. So this is 5, oops, I don't want that. 5/2 and -1. And then part 2 of 2, radius is 5/2. Just coincidence there. Right? Fantastic. So I'm going to stop us there and let you go. And I'll post this and just give you kind of a walkthrough for the first bit. If you have questions about something I've missed, please ask. Okay. Make sure you do your knowledge check so you can get actually started with this. And I do these lessons every day because we have a 7-credit class, so we are in class a lot. All right. So with that, I'm going to go ahead and say good night to you, and I will hopefully see you again tomorrow.